talked about cases where there's some linear relationship, right? In that case, we say there's a linear association, and when there's a linear association, there are two possibilities, right? Either a positive association or a negative association. So the positive one is obviously when x increases, y increases. Negative is when x increases, y decreases. So if you were to see these scatter plots, you're instantly able to tell that it seems like there's some kind of a linear relationship between the two. And the line of best fit would look something like this in this case, or something like this in this case. So it says association here. Another possible word in this case is correlation. So we say that there is a positive correlation in this case, and a negative correlation in the next one. So this is the case where there is a linear association, but there could be some kind of non-linear relationship between the two. So you might draw a scatter plot and you might get some image that looks something like this. And we see that this actually looks roughly like exponential growth, right? Exponential growth looks like this. So it looks like there's some kind of an exponential relationship between y and x. And so this isn't the line of best fit anymore, right? It's like the curve of best fit, although we don't really say that, but I guess that will be the term for this. And we see that the y is related to x through an exponential relationship, or an exponential association. And that means an exponential curve can be fitted to the data points. Then we have, or we could have, for example, a quadratic association, or a quadratic relationship, right? So we see that we can fit a parabola to these data points. So in this case, that means that x and y have some kind of quadratic association. So remember that, take note that positive and negative association, those really only make sense in the context of linear relationships. So when you have a linear relationship or a linear correlation, we can see it can be either positive or negative. But for example, that wouldn't really make sense in the context of quadratic equations. So I already covered among non-linear relationships, we only looked at exponential and quadratic associations, but it could be anything. It could be like a cubic association, or like a sine or trigonometric association. But the most common ones are usually exponential and quadratic. And then the final case is when there's no obvious relationship, there's no association. We can't really fit any line or curve to this data, to these data points that would approximate the data points very well. So in this case, we can say there's no association or no relationship. Now, a point of caution that probably won't come up in the SAT, but it's something helpful to know in general is, you might have heard of the phrase, correlation does not imply causation. So if we look at something like this, just because we see that there's some kind of a relationship between x and y, we can't infer anything just from this information. We can't infer anything at all about cause and effect. So we don't know if x causes y or y causes x, or if it's neither. So for example, you might have a scatter plot that looks like this, which on the x-axis you might have children's shoe sizes. And on the y-axis you might have reading ability. So each of these data points represents a child, and the x-coordinate is the child's shoe size, the y-coordinate is the reading ability of the child. And we see a positive linear relationship here, right? But you can't infer anything from this in terms of cause and effect. So you can't just look at this and say, oh, that means people who have bigger shoes have better reading abilities. Or the other way, you can't say by having a bigger reading ability, that means you have a larger shoe size. Neither of them are actually causing each other. If you think about it, it's actually because the reason for this association is just that, generally speaking, the older you are, the older a child is, the larger their shoe size will be, obviously, right? Because they're growing, and also, obviously, the greater their reading ability since they're growing up. So age is in fact what's causing both of these. So you can't draw any information, you can't draw any conclusion about